Welcome to this product demonstration, presented by the ChatillonGPT team. Step into the intricate world of ChatGPT and unravel the mysteries of its inner workings with us. Today, we demystify what GPT and LLM truly stand for, by dissecting the acronyms and exploring the mechanics beneath. Then, we'll channel this newfound understanding to construct a simple, Shakespearean-like GPT. Join us on this enlightening journey where technology and classic literature intertwine, revealing the marvel of artificial intelligence in crafting poetic narratives. Now, I'll turn it over to today's speakers to show it all in action.
Good morning, everyone. I'm sure you know, but I am John and this is Jacob, and we are two software engineers here at Kingsmen, and today we're going to be talking about ChatillonGPT. So we are going to be exploring how ChatGPT works, and we are going to build our own with a little help from Shakespeare. So first off, what is Chatillon? Chatillon is a character from the Shakespeare novel King John, and we found it fitting for the name of this project that Jacob here created. Yeah, so what is a GPT? It's a type of LLM, right? And what's an LLM? That's what we're going to be talking about today. So the two things we're going to explore today, GPT and LLM, and then at the end, we will be making our own. Kind of. So let's dive into their acronyms and break down what they actually mean. We will start with LLM, so I will hand it off to Jacob.
So the first L in LLM stands for large. Means it's big. So what's big? So it's the large amount of data that was used to train ChatGPT. So how much data are we actually talking about? Well, we're talking about 45 terabytes of text. So to some, that'll be you'll understand how big that actually is, but to others, let's get a baseline here so that we all understand how big 45 terabytes is. So 1 terabyte is 1 trillion bytes, and 1 byte is equivalent to about 1 character. So this L right here on the screen, that's about 1 byte worth of data. So let's say, for example, here, 1 grain of rice, the size of 1 grain of rice is equivalent to that 1 byte of data. So how big is that? So let's picture, so how big is a trillion grains of rice? Has anybody ever seen a cargo ship? That's a cargo ship. It's big, isn't it? It's massive, huge. So let's ask this question. How many cargo ships will it take to hold 1 trillion grains of rice? 2 cargo ships. So 1 terabyte is equivalent, in our example here, to 2 cargo ships of rice. So if we did the math correctly, if I did my math correctly, John double checked for me, that's 90 cargo ships of rice. That's massive. Just think about how big one cargo ship is, and just 90 of those. And for our example here with ChatillonGPT, we trained it on all the works of Shakespeare, and so that's equivalent to 8 bags of rice. So that's large. So let's get on to language. Now this is a smaller piece of, not as much to talk about here, but language means it's been based in language, meaning it receives language in some format, text or audio, and as an input, and then will output text or audio. So that's language. So now on the model. So think of model as a student. So picture back being in school, back in your school days. In school you would learn a subject. That's your data. That's the books that you're reading. And with the aid of an instructor or teacher, you'll have a lesson plan. And so you'll be fed this information in a format that you can understand and better process. and that's your ML algorithm. And then you would, after you've learned the subject, got your degree or passed the class, you would then be able to apply what you've learned to future problems. And that's your prediction.
Cool, so yeah, that's an LLM. And now that we know what that is, we are going to dive into GPT.
So the first G, or the only G in GPT is generative. It means it generates, it creates something new. So if I prompt an image generating GPT or an image generating AI model, I say, hey, create me an image of cats wearing party hats reading emails in space, it would then generate an image that looks like that, given a prompt. That's the generative piece. Now the opposite of this is a discriminative model, meaning it classifies. So a question would be that you would ask a discriminative model would be, hey, are there cats in this image? Or how many cats are in this image? And so an image generating model, a discriminative model would be able to find cats in this picture. If you were at the Expo, you would have also seen crack detection, which crack detection is an example of a classifying or a discriminant model. So now on to P, which is pre-trained. It means it's already been trained. That's what pre-trained means. So you could take that knowledge and know that anytime you prompt ChatGPT, it does not use that data that you give it to train any further, because it already has that massive 45 terabytes, 90 cargo ships of rice, and has already been trained off of that massive data in a format that it can understand. But the takeaway with that is that it's not been, or has already been trained and is not using your data. So this kind of begs the question, what is training? Well, training is a loop. Class is in session. So imagine, it's your first day of class again. Imagine being a student once again. You're walking to class, you enter the classroom, you have no knowledge of this subject that you're about to learn. But as you enter the classroom, you notice people are taking a test. There's a kid, he's crying for mama in the corner of the room. It's very, very, very sad sight. So the teacher is forcing everyone to take an exam of this unknown subject. But don't worry, you can take this exam as many times as you want. The teacher tells you that. But you cannot leave the classroom until you pass. And you can take as many times as you want. So you take the exam. Once you finish the exam, you go up to the teacher. The teacher tells you which questions you got right and which questions you got wrong. You then adjust, and that's the key point here. You adjust, and then you can go back and retake the exam, and hopefully next time get closer to that passing grade that the teacher is looking for. And that is what training pretty much is. Training for a model is that loop of take the test, see how close I got to the answer, and then adjust and repeat until I get closer to the correct answer next time. And at the end, we will have a model that can successfully generate output based upon the training and new user input. So that's pre-training, and that is a little bit of a rundown of what training is. So now on to transformer. So this is the most complex piece of this talk. It's very complex with the math that's involved with it, and so we're going to take a very high-level approach as to what the transformer intends to do behind the scenes. So transformer, to be very simple here, transformer keeps track of what has been said. It pays attention to more important words, and then it generates new text that makes sense based upon what it's read. It's all about context. So an example here, so if I was to prompt ChatGPT to say, hey, complete this sequence, A, B, C, D, what letter should come next, or what should come next? Well, because of the transformer, the GPT will be able to, or the transformer piece, allows it to say, hey, the next letter, let's see which letter that stop at, A, B, C, D, E, I stopped at D, right? Okay, A, B, C, D. It would say, hey, E is the next letter in the sequence, and that is what the transformer allows it to do on top of the massive training set that it learned off of. Yeah, that kind of describes pretty much what a transformer is, and attention is all you need. That was a research paper written back in 2017. And that is where the transformer was initially conceptualized. They were actually having, and the problem that this paper was trying to solve, they were having issues with older chatbots or chatbots that didn't have transformers. They're having issues with it keeping track of what has been said. And so it would, say, hey, you would prompt a chatbot that didn't have a transformer piece in it. You would say, hey, write me an article about elephants. And so first paragraph, it'll stay on topic. Then all of a sudden, the next paragraph will be, hey, what's your favorite color? Mine's pink. So it wouldn't stay on topic, and that was the issue that they were trying to resolve there. Plus, the transformer allowed a more efficient memory mechanism, because some of them, they did have memory mechanisms, but it took up a lot of resources, and this sort of mimics a memory mechanism without actually having a memory mechanism. So that's a transformer.
Right, so now that we know what ChatGPT is, a generative pre-trained transformer that's a type of LLM or large language model, we can make our own. Yeah, so what is ChatillonGPT? ChatillonGPT was made by our very own Jacob here. It was trained on all the works of Shakespeare. That's about a megabyte of text, or 8 bags of rice. These are the farm kind of rice bags that you see. It took about 12 minutes of training time on high-performance consumer-grade hardware. Jacob utilized the PyTorch library for building the neural network out. It has about 6 heads of attention, the transformer, and GPT-4's estimate is around 120 to 150, so
It's really, really tiny.
right, yeah, so there's a big difference here between the two. And the whole idea of it is that we give it some input and we expect Shakespeare-like text as an output. It's a great proof of concept LLM that you can expand upon to accomplish specific needs.
All right, so let's demo. So this is a ChatillonGPT. What's called Shakespeare GPT here, because that's before we decide our incredibly clever name. It has a prompt here, just like ChatGPT, where you can prompt it, giving it a piece of context, and we'll feed it some information here, and it'll then try to build Shakespeare based off of that. So we're going to feed it a character, so as if it's part of a play, we're going to give a character, and then we're going to basically say, hey, this is the expected line that we have for the character. So Lady Capulet, is that right? That's it. And then we're going to do colon, and that way it can build off of that. So you'll see in just a moment. So what's going to happen here, this is going to go beyond the screen though. What's going to happen here is this is the context that we fed it. We throw it to the model. The model will then, we have to say, hey, generate 500 new characters of Shakespeare based upon this context that we gave it. And it's going to build off of that. We'll see in just a moment here. So as you see, okay. So we have Lady Capulet. We fed that into the model. See, almost as if it repeated what we said, which it did because it's building off of the context, as I stated repeatedly. We have Lady Capulet. Based upon that context, it says, okay, what should be the next word that should come after Lady Capulet, colon. And it says, hey, fellow. So Lady Capulet, colon, fellow. And then it takes that context again, Lady Capulet, fellow, and then throws it to the model again and says, okay, what should come next after Lady Capulet, fellow? And it's Lady Capulet, fellow, come. And then it continues that building, so I can just keep repeating it. So with Lady Capulet, fellow, come, my son, we must all err we good. So given what Lady Capulet said here, we throw it back to the model, and so on and so forth. It finds that Samson should be the one who talks next. And we have this pattern here of it building off of that context given the previous context. And that's that transformer piece. When we feed that context of how it determines what should come next. Let's see. And right at the top, it seems like the conversation doesn't seem to make much sense. But as we get to the bottom, as our context window expands, we get to the point where it almost seems like one person is talking to the other, because at the top it seemed like people are just sort of just saying things. And as you see down here, we have Capulet, welcome, Gwallers. He had not like you. And the first servingman almost seemed like they're replying to him. They say, aye, and to one, I'll stay, he will. So that's an interesting thing. As this context window expands, it becomes more coherent, but still it doesn't fully make sense. Now,
Yeah, so the only context it has is Shakespeare, right? It's the only context it has are the works of Shakespeare. It hasn't been trained on actual human conversation, right? So that's why it outputs text that looks like Shakespeare, comes across like Shakespeare, follows the same pattern as Shakespeare. But we'd have to train it a lot more with a lot different types of training data to actually get it to have a full Shakespearean conversation.
Right.
And more heads of attention, right?
Yeah, exactly, yeah. More heads of attention, it'll get more precise. Again, the way this is reciting Shakespeare is similar to an example I gave was, imagine trying to draw an animal from memory, like an elephant. So if you try to draw an elephant, it will look like an elephant, but it's clearly not an elephant. It's like a low resolution elephant that lacks the details. This looks like Shakespeare if you kind of cross your eyes a little bit, sort of a blurring of it.
Could you train it on other data?
Oh yeah, absolutely. This is what we said in that previous slide where it's a great proof of concept LLM. I could feed it, any text, and it'll generate text that looks like that text. So I could feed it all the works of Stephen King, and we could build an LLM that just spits out Stephen King-like text. If he has a certain writing style, I'm not fully certain. I haven't read any of his books because I'm too scared to. But